So this week we want to talk about fronts, but before we can do that, we need to talk about air masses, because a front is just the boundary between two air masses. And air masses come in a number of flavors. You've got polar air masses, which are cold, represented by the P, warm air masses, tropical air masses, represented by a T, continental air masses that start out over land and are dry, represented with a lowercase c, and moist maritime air masses, which are represented by this M. And you can create this kind of grid to remember how these air masses are classified. So cold and dry is continental, polar, M and T, maritime, tropical, moist and warm, or moist and hot. And you can see how these air masses impact the United States. You have maritime polar air masses impacting the northwestern United States and northeastern United States, whereas our region is generally impacted by continental polar air masses that form over Canada and bring cold, dry air to us. That's what impacted us for much of the winter. And they're interacting with continental tropical and maritime tropical air masses that move in from the south, bringing moisture, allowing for storms to form. So we have temperature, hot or cold, and moisture, moist or dry, but we haven't really talked about the stability of these air masses. And you can see this continental polar air mass, cold, dry air mass, is sitting over the United States. And you don't see many clouds, maybe a few back in this area, but not many clouds. Again, that's because it's cold, dry, the stability is pretty much set. But then this air mass moves over a warm area of water, so warm, moist air. You've got the opposite of the cold, dry air mass. That changes the stability and it allows air to rise and clouds to form. So basically, this interaction, this air mass moving out over this water, this body of water, creates a stability change, creates rising air, and that allows clouds to form. This process is vitally important for understanding something called lake effect snow. Many of you who've been in the Midwest for a long period of time will know this term because it directly impacts a lot of areas, as you can see in this map here, that are drastically impacted. They get a lot of lake effect snow. And what's happening here is an air mass forms. So an air mass that started in Canada starts moving down and it comes over these Great Lakes. So a cold, dry air mass is moving over a warm lake that picks up energy, picks up moisture, that changes the stability, causing rising air, clouds form, and then as the air continues to rise, that moisture deposits and condenses into snow and dumps snow on the opposite side of the lake as it moves through. But lake effect snow isn't the only way you can impact these air masses and modify them. You can start out with a maritime polar air mass in the North Pacific, moving into the United States, onto the west coast. You're bringing in cool, moist air. You hit the mountain ranges, the Olympic mountain ranges, the Cascade mountain ranges, and eventually the Rocky mountain ranges. And this air mass is forced up and over. Each mountain range it's forced up and over, it causes rain. It loses some moisture, so it's drying out. Each time it moves down after drying out, again, thinking about the stability and the dry adiabatic versus wet, moist adiabatic lapse rate, it warms up. And so it's drying and warming as it passes over these mountains, and you end up with a modified, dry, warm, maritime Pacific air mass. So where the air mass ends up is vitally important, and where it is right now, to understand what the current conditions are, because they can be modified. They can change over time.